Hi guys, my name is Terry. In this video, I'm going to go through Additional Mathematics Form 5 textbook question, Chapter 5, Probability Distribution, Formative Exercise 5.1. Again, as usual, if you enjoy this video, can you like, subscribe, and comment? Alright, let's get straight to this. So here, the first question is about school with a debate team of 6 people. 2 of them are boys, 2 members are randomly selected. So an X present number of boys selected. So list the possible outcome. Now, you can choose to draw out a tree diagram like this, but it's actually not necessary. So we have to choose 2 people. You can have boy, you can have girl, you can have boy, you can have girl. Now, in this case, we want to choose 2, and out of 6 people, 2 of them are boys. So actually, it doesn't matter if you want to write 2 over 4 girls. 2 over 6 girls would be 4 over 6. You can do that if you want, but I think it's not necessary, right? So don't have to list all this. So we know you can have boy and boy, boy and girl, girl and boy, girl and girl. So this is how the tree diagram should look like. But what we're interested in is X, the number of boys that we can get. So maybe I add in here X. The first one you have 2 boys, second one you have 1. You have 1 boy and 0 boys. So the possible outcome we can write in this manner: 0, 1, and 2. Alright, B. State whether X is a discrete random variable or continuous. Answer is discrete random variable. Remember, discrete random variables are for quantity that's countable. You can count a number of boys. Yeah, it's 1, 2, or 3. You cannot have 2.5 boys, right? Yeah, it's either 2 or 3. So, yeah, for measurable quantity, that's continuous random variable. Okay, let's go straight to question number 2. All right, so it's found that the longest nail produced by a factory is 10.2 cm and the shortest nail is 1.2 cm. So if X represents a random variable for the length of nails produced by the factory, list all the possible values. Right, now, unlike discrete, you cannot use a tree diagram to list out, to see all the possibility, right? Because here we are talking about drawing only one nail, but that nail can have any length, right? So normally when we write for continuous random variable, this is a continuous because length is something measurable. We usually represent it in a set notation like this: X equals to put X dot dot, and you have to describe what is X. X is the length of nails, and put in the unit in cm, and then we use the what they call that inequality to represent this. 1.2 is the shortest, the longest is 10.2. It's inclusive, including. Yep, this is how we represent our answer. All right, second part, state whether X is a discrete or continuous random variable. Yeah, as you know the answer is continuous. Let me write nicely: continuous random variable. Right? Okay, let's move on. Okay, so next question number 3. Okay, this question we have to use a graph. We have to draw a graph, but first we have to show that X is a discrete random variable. You're given a table. Yeah, we call this a probability distribution because it's like how the X value, they are distributed according to different probabilities, right? So in order for you to show that it's a discrete random variable, all right, with a probability function, that's basically we just have to show that the total probability is 1. And remember, for any random variable, if you add up all the probability, is always 1. So let's just rewrite here: sum of probability. You can write Bx equals to R like this, right? It simply means the first one, probability is 0.2. You add up with the second one, 0.35. Add up the third probability, 0.3, and last one, 0.15. Add up all this and you can get 1. Yeah, if I can show that it's true, therefore X is a, maybe I can just use short form DRV. DRV means what? Discrete random variable with probability function. X equals R. dpx equals R. Okay, that's it for the first part. All right, second part. Now we need to draw a graph, the graph for X. So to draw this graph, right, I need to use a graph paper. So guys, I show you here. Now, please refer back to the table here. I can't show you up here. So, all right. So when it comes to the graph for probability distribution for a discrete random variable, right, it's a little bit different. Yeah, as in different from our normal graph that we always draw. Okay, first thing, I'm going to draw the horizontal line here. So guys, I'm not going to use ruler because it's going to take very long. So I'm just going to use freehand. Sorry for the ugliness if my line not straight. Kind of gay, sorry about that. This is 0, 1, 2 and 3. This is x equals to r, and this is my probability here. Man, hard to draw a straight line. Yeah, I don't want to use the ruler tool. The ruler tool is very slow. This one, oh, very slow. Yeah, I don't want to do that. Yeah, so I'm just going to use pencil. All right, so this is bx equals to r. So we'll use 0 0.1, 0 0.2, 0 0.3. The highest or the largest value I can see from the table is 0 0.35, so we don't have to go beyond 0 0.4, right? But if you want to label 0 0.5, go ahead. Now, why this graph is a bit different from normal graph? You see, normal graph, if you draw the graph, right, we can put the points and we join together, right? Because normal graph, if I say a function y versus x, right, you can have various value for x and y. But here, no, you can't. You have only x can only take a specific value. For example, if you refer to the table, your x can only take is either at 0, 1, 2, or 3, and nothing else, right? So at 0, your x value is 0 0.2. So let's here put a cross. Then you draw an impulse graph, draw a line, vertical line. Okay. Now next, at 1 is 0 0.35. 0 0.35 is over here. You put a cross, line downwards. Right? Okay. 2 is 0 0.3. Put a cross, line downwards. Then 3, 0 0.15. You put a cross, downwards. Alright? And nowhere else. At 0 0.1, 0 0.15, 0 0.25, 2.3, they're all 0. There's no probability. The probability values are all 0. Okay, so that's how my graph just looks like that. Okay. Alright, so that is question number 3. Okay, let's look at question number 4. Okay, move it up. So here we have a box that contains several table tennis ball. Each table tennis ball is labeled with number 1 to 10. So the probability of selecting 135 is 0.2. Probability of selecting 2, 4, 6 and 8 is 0.1. Okay, a tennis ball is drawn randomly. Return to the box, and after the digit is recorded, and then they repeat 3 times. Okay, so to list out the possible values, and later we have to show that it's a discrete random variable. I think we can draw a tree diagram, but when you draw a tree diagram, just make it very simple, right? Because what we want, what we're interested in is what? Look at this. I want the number of times x equals to 135. Okay, I can't show you here. 135 are selected. So if you want to use a tree diagram like to represent like 1, 2, 3, 4 all the way until 10, it's going to be crazy because you're going to draw 3 times, because you're going to draw, you know, this time I'm drawing the ball 3 times, right? So I'm just going to make it simpler by focusing on the number of times we draw 135. So let's say 135 we can say is A. A represent the event of getting number 1, 3 or 5. Now A bar is the event of not getting 135. Okay, now we know the probability of getting 135 is now 0.2. Can you see? So this is 0.2. Everything else will be 0.8. So this is your first draw. Okay, now in your second draw, this is A, this is your A bar, this is your A, this is your A bar. In your third draw, okay, I put a second draw here. This is your third draw here. You can either get A or A bar, A or A bar. Remember, A means getting 135. A bar means not getting 135. Alright, so now you can label everything 0.2, 0.8, 0.2, 0.8, and so on. Right? Okay, the next thing is, what you want to do is we want to find out the possible values of x. So I'm going to write down here this your possible outcome, your A can be like for the first case, right, we can get all three 135. That means A, right? Second one is A bar. Next one is A bar, 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 and A bar. So there are 8 possibilities. Now then we look at our x. Okay, the first one, remember, we are interested in finding how many x we can get. We can get 3x. All three, x equals 3 means all 3 of them are 135, right? This one is 2, this will be 2, this will be 1, only one A here. This one is 2, this is 1 A here, this is also 1 A here, this is none, 0. So if I were to list out my possible outcome, okay, let me list out here. Your x value can either be 0, 1, 2, or 3, maximum 3. Okay? Alright, I hope you can see this. Alright, so now the next thing is I want to show that it's a discrete random variable. Now this one is a bit troublesome, not impossible, but just troublesome. You have to find the probability one by one. Okay, so now the probability of getting x equals to 3, alright, if you can see from here, it will be what? 0.2 times 0.2. Let me use a highlighter. 0.2, 0.2, 0.2. So this probability, you can say, is 0.2 power 3. We can write this as 0.008. Now for 2, right, you can see there are 3 cases we get 2. Yeah, bx equals to 2, there are 3 cases. Yeah, maybe we take the first one, and we know it's going to be the same, like the first case. Maybe I use red pen. I can get 0.2, 0.8, sorry, 0.2, 0.2, 0.8, 0.2, 0.2, 0.8. So that means we can write 0.2 times 0.2 or 0.2 square times 0.8, right? So whatever we get, we multiply by 3, because there are 3 cases to get x equals to 2. In this case is 0.096. Okay, let's look at the cases where you can get 1. I have 1 here, 2 here, 3 here, right? So maybe I just highlight one of them. It can be this one, and this. That means the first one is 135. Second and third, they're not 135. So we can use bx equals to 1. There are 3 cases. The first one is 0.2. Now you notice that is 0.2, 0.8, 0.8. They are double 0.8, single 0.2. So 0.8 times 0.8, we can write 0.8 squared. And this will give us 0.384. And finally, when x equals to 0, okay, it's all 3 here. Let me just use a different color. Maybe I use yellow, 0.8, 0.8, 0.8. So this will be 0.8 cube or 0.512. Okay, but I need to add them up. Yeah, I need to show that the total probability is 1. You can put it in a table, though. All right, so I can just use a table over here. Let me move up a bit, right? Let me just squeeze in here. So you can use a table x, b, x equals r. This is just 0, 1, 2, maximum 3. Okay, over here. Now, my first probability for x equals to 0 is 0.512. X equals 1 is 0.384. X equals to 0.096. Last one 0.008. So to show that this is a discrete random variable, yeah, for a discrete random variable for what do you call that? Probability function x, bx equals to x. You can write in this form. You can even write x equals to r. Yeah, if you want. Let's say I write the bx equals to r. That means the first probability is 0.512 plus 0.384 plus 0.096 and 0.008. Use your calculator. The sum is 1. So we can conclude that therefore this is a we say that it's a what? Okay, let me use the right word. Wait, yeah. For the question, the question says show that it's a discrete random variable with probability function. So we just write, therefore it's a discrete random variable with probability function Px equals r. Sorry, I don't have enough space, so I'll just write this. Okay, now the next thing we have to draw the graph. Yeah, part C, draw the graph. Okay, so now my graph must be based on this table. So again, horizontal axis over here. Yeah, this is, you can write x, you can write x equals r, up to you. So this 0, normally we don't put 0 on the vertical axis because you can't see that. If I draw 0 on the vertical axis, I really cannot see the line. So we put 0 here, 1, 2, maximum 3. Okay, and then I can see the largest 0.5, 512. So this is 0.1, 0.2, 0.3, 0.4, 0.5. Maybe we extend all the way up. This is 0.6. This is Px equals r. Okay, for 0, I get 0.512. Now we can only read up to half the smallest boxes. So that means what? 0.51 or 0.52 or even 0.515. Yeah, up to you. Maybe I draw 0.51551 here, right? Draw a line downwards. Please use a ruler, guys. Sorry, I'm not using ruler, freehand. Okay, for x equals to 1, 0.384. 384 will be over here. Draw a vertical line downwards. X equals to 2, 0.096. Very small value, 0.099 is here. 96 in between, 95. Yeah, between 0.09 and 0.1. Okay, lastly 0.008. Very small, less than 1. 0.1 is here, 0.08 somewhere here. Yeah, very, very small value. Okay, so that's for number 4. Yeah, okay, let's move up. Question number 5. So here you're given x equals 0, 1, 2, 3, 4 is a discrete random variable, probability given as below. So given that p is twice the value of q, find the values of p and q. So basically we have to form 2 equations and solve them simultaneously. Well, the first equation is already given, right? P equals to 2q. The second equation, we know that our sum of probability is always 1. So p plus q plus p plus q plus q plus q. I say this again, p plus p, not p plus q. P plus p plus p plus q plus q plus q is going to give us 1, right? So this is 3p plus 3q is 1. Well, you can call this equation 2, sub 1 into your p is now 2q, right? This is 6 plus 3, 9q is 1, q is 1 over 9. Okay, so once you got q, we sub inside equation number 1, p is 2 times 1 over 9, answer is 2 over 9. Okay, right. Alright, let's move on to the next question. Okay, the next question is quite long, right? Question number 6. Okay, so a player will be awarded 1 point if he wins a chess game, half point if he gets a draw, and 0 point if he loses the game. So Lee plays 3 sets of chess game. Construct 3 diagram. Wow, this is super duper long. Yeah, I think, yeah, we need to reserve some space. Okay, so now I'm gonna move this up a bit, and yeah, you have to, yeah, I'll start from here. Okay, well, I wonder whether I can put everything in. Yeah, okay, 1 point, half point, 0 point. So let's just get going. Just draw here. So now first thing you have to start, let's say at this point I branch out to 3 branches. Yeah, try to draw as far as you can, because it's going to be very big. 2, 3. Okay, my line's a bit not so straight, sorry about that. Okay, so when you play the first game, there are 3 possibilities. You can win, you can draw, or you can lose, right? So the second game also, this is your first game. Second game, you can win, you can draw, you can lose. win, draw, lose, win, draw, lose. Okay, we can see that. This is your second game. Okay, third game will be a bit difficult to squeeze in. Win, draw, lose, 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 win, draw, lose. You can see, really we need a lot of space. Maybe this one I draw a bit lower so that, yeah, I can squeeze in everything, right? A bit lower here, lose. So this will be win, draw, lose, win, draw, lose, win, draw, lose, win, draw, lose. You can see if it's 3 possibility for each game, each set that he played. So 3 power 3 will give us 27. That's what that 27 option. So my outcome, I'm going to write here, my outcome, oh, this is crazy, very long. Win, win, win. I can win 3 sets game, three straight sets. So second one is win, win, draw, win, win, lose, win, draw, win, win, draw, draw, win, draw, lose, win, lose, win, win, lose, draw, win, lose, lose, draw, win, win, draw, win, draw, draw, win, lose, draw, draw, win, draw, 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 lose, draw, lose, win, draw, lose, draw, draw, lose, 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 win, win, lose, win, draw, lose, win, lose, lose, draw, win, lose, draw, draw, lose, draw, win, lose, lose, win, lose, lose, draw, lose, lose, lose. Total 27. This is amazing, right? Okay, so yeah, I've got my tree diagram, right? But I'm not done. What we need to do is we need to construct a tree diagram, show all the possibility, right? And X represent number of points he obtained. Okay, remember he gets 1 point for a win, half a point for a draw, 0 point for lose. So when, okay, I'm gonna add in here, this is your points. If you win 3 games, how many 3 sets, how many points you get? Each point, each win you get 1 point, 3 wins 3 points. Now win, win, draw, 2 points for each win. I mean 1 point for each win, so it's 2 points plus half a point for draw, so you get 2.5. Win, win, lose is 1 plus 1 plus 0, which is 2. Win, draw, win is 1 plus half plus 1, which is 2.5. Win, draw, draw is going to be 1 plus half, which is 2. Win, draw, lose, 1 plus half plus 0, 1.5. Win, draw, win, win, lose, win, 1 plus 0 plus 1, 2. Win, lose, draw, 1 plus 0 plus half, 1.5. Win, lose, lose, 1 plus 0 plus 0, which is 1. Win, draw, draw, win, win, 0, half plus 1 plus 1, 2.5. Draw, win, draw, 1, 0. Half plus 1 plus half, 2. Draw, win, lose, half plus 1 plus 0, 1.5. Draw, draw, win, half, 1, which is 2. Triple draw, half. Yeah, so 1.5. Draw, draw, lose, half, 0, so it's just 1. Draw, lose, win, half, 0, 1, 1.5. Draw, lose, draw, half, 0, which is 1. Draw, lose, half, 0, 0.5. Lose, win, win, 0, 1, so 2. Lose, win, draw, 0, 1, half, 1.5. Lose, win, lose, only 1 point for the win, 0 for both losses. Lose, draw, win, 0, half, 1, 1.5. Lose, draw, this will be 0, half, half, which is 1. Draw, lose, 0, half, and 0. Lastly, 3 more, sorry, loss, lose, win, 1. Lose, draw, 0.5, and this is 0 points. Man, this is very, very long. So there are 27 possibility, but you notice there's some of them that you're getting actually the same number of points. So okay, because I would need to find the probability, right? So I think, okay, I'm gonna list out my possible outcome first, right? Possible values of x. I say construct tree table, represent possible outcome, x number of possibility, list the set of x, okay? And after you list the set of x, you draw two graph. We need to find probability, right? I need to find the probability anyhow. So I'm just going to list out first the x value. So you can see the smallest value of x I can get will be 0. I can also get 0.5, right? I can get 1, right? I can get 1.5. I can get 2. I can get 2.5. And lastly, I can get 3. So this is the answer for the first one. Okay, but I need to draw a table so that I can draw the graph later. So for the table, before I draw the table, let's calculate all the probability. Let's start with 3, because I can see that 3 is the all 3 win. All 3 win will be, let me use, so get yellow, maybe win. So okay, the probability of winning, let me see. Now, the question actually didn't actually mention what is his chance of winning. So we just assume that the chances of him winning, drawing, and losing are all the same. They're all 1/3, right? So you notice the question that I say they only mention about what they call it, the points given, and they mention that Lee, okay, what is the chance of Lee winning? Yeah, so no, nothing stated. So we'll just take 1/3, 1/3, 1/3. That means the probability of him winning, drawing, losing are the same, right? So this was 1/3, this was 1/3. All right, so all 3 win will be 3 points, right? So it'll be 1/3 power 3, 1/27. Okay, let's look at 2 wins. Okay, 2.5 points first. We talk about points, not wins. Sorry, talk about points. Okay, 2.5 points. Now, in what situation get 2.5 points? So I'm going to use here 1, 2. Okay, this will be 3. Then yeah, only 3, right? Okay, but since the probability are all the same, they're all equal. You see, you don't believe me, you can just list out what is the chances here. 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. So this is easier. You don't have to bother about like, okay, win the chances higher, lose chances smaller. So we know that they're all 1/3, but I have 3 cases of them. Each one is 1/3, so you power 3, so it's going to be 3/27. Now you can also write 1/9, right? 3/27 or 1/9. So I'll keep the 3/27 so that it's easier for me to draw the graph later, because they all have the same denominator of 27. Okay, how about x equals to 2? Okay, let's look at 2 points. Use blue color. 2 points: 1, 2, 3, 4, 5, 6. There's 6 of them. So the probability of getting 2 points is 6 of 1/3 cubed. You can write 6/27 or divide by 3, top and bottom, 2/9. Then let's look at 1.5. Okay, what's the probability of getting 1.5? Let's count. So here I'm going to use, what color haven't used? Blue, green. Okay, I'm going to use green. Okay, 1.5 is 1, 2, 3, 4, 5, 6, and 7. There are 7 cases where he get 1.5 points. So 7 times 1/3 power 3, 7/27. All right, then let's look at 1 point. Okay, so the chances of you getting 1 point. Okay, what color should I use? I think I use back yellow. Okay, 1 point would be here 1, 2, 3, 4, 5, and 6. There are 6 cases that he get 1 point. So we write 6 times 1/3 power 3, 6/27, or 2/9. Next, let's look at 0.5 points. Okay, here I'm going to use red color. All right, so 0.5, where is it? Okay, I start from bottom. 1, 2, 3. There are 3 cases where you get 0.5 points. Yeah, so that will be 3 times 1 over 3 cubed, so 3 over 27 or 1 over 9. And lastly, 0 points. 0 points are easiest. There's only one case here. He lose all the games. All right, so it's just 1 over 3 cubed or 1 over 27. So now that I have all the probability, yeah, oh, this is very, very long. Now I need to put it in a table, right, so that I can draw the graph. Okay, so guys, you have to like refer back to this page, right, this screen to map everything on in a table. Okay, so I'm going to show the table in this page. Okay, so that's easier for me to draw the graph. Now, wow, my graph, I can tell you, wow, a bit hard to see. Yeah, so I can't squeeze everything in a page, but I will just show you the table first. All right, I'll map it on the table here. Right, oh, line a bit off. Okay, so this is x equals to r, this is b, x equals r. I know the smallest is 0, and if the first one is 1 over 27. For 0.5 is 3 over 27. Now you can write 1 over 9, but I think 3 over 27 is easier because every term has common denominator at 27. So next one is 1, 6 over 27, 1.5, 7 over 27, 2 is 6 over 27, 2.5 is 3 over 27, and 3 is 1 over 27. So I've got this thing done, right? Okay, so the next step is this. I need to draw this on the graph paper given here. So now I'm thinking to change everything to decimal, but I see, look at the numbers are all multiple of 1 over 27, so we'll just use the multiple. Yeah, it'll be easier. And I need 7 boxes. All right, I need up to here. So now my horizontal axis is here, very, very long, right? This is my x equals to r. Okay, maybe I'll move it up a little bit first, right? So it's easier for me to write. This is 0. Okay, remember, I don't put 0 here. I put 0 for the probability, but not 0 for the x. X should be here, 0 here. 0.5, 1. You can write 1.0 though. 1.0, 1.5, 2.0, 2.5, 3.0. Yeah, this represents number of points that he get. Okay, for y-axis, to make it easier, because you can see they're all multiple 27, multiple of 1 over 27. So I'm just going to use 1 over 27 here, 2 over 27 here, 3 over 27, 4 over 27, 5 over 27, 6 over 27, and my largest is 7 over 27. Well, yeah, a bit hard to squeeze everything in. So yeah, there you go, 7 over 27. Okay, I may have to move this up so that you can see later on. Okay, so start with 0, refer to the table. 0 is 1 over 27, so I put a cross, draw a line. 0.5 is 3 over 27, put a cross, draw a line down. Okay, for 1 is 6 over 27, so it's up here, vertical line. Man, this is ugly. Should I use a ruler? Okay, I use a ruler. Probably looks nicer. Yeah, I hope. Wow, a lot nicer, man. Yeah, but it's a bit slower using a ruler. Just look a lot nicer. Yeah, highlight a bit more. Okay. Okay, now let's look at 7. 7 you draw all the way up. Yeah, all the way up here. Yeah, my line a bit thick. Can't really see the difference. Okay, and then next one is for 2.0. I think I got 6 over 27. Okay, and for 2.5 I've got 3 over 27 would be here, and for 3.0 I got 1 over 27. Yeah, so this graph paper is a bit too big in a way. Yeah, okay, but I'm using a standard graph paper here. So okay, so erase this, put a cross. Remember to put a cross for each value here. Cross, cross, cross. This one I move up a bit so you can see the cross here, right? So my graph is almost done. There you go. Can you see? Just the 7 is really hard to see, yeah? 7 over 27. And remember to label the axis, right? This is bx equals to r. All right. Oops. Wow, this is a little bit ugly, right? So there you go. All right. So that's the end of this practice. So again, yep. If you enjoyed this video, yep, you like what you see here, and we have more modules, books, past year question. Yeah, you can actually get some of this from our Shopee account, yeah, or you can get in touch with us if you're interested in our classes and also our learning modules. All right, so you can visit Shopee, look for Perceptual Utility, and find us there. Thank you very much for watching this video. Hope you learned something from this. All right, see you in the next video.